Oh, great. Let me check, it's loading. Okay, let's wait 1 minute and.
Okay, no problem.
Yes. It's my first time I run live on YouTube. That's why I'm a little bit nervous if it's working. Okay. Oh, great. Okay, great. We are here. We are live, and we can start the workshop. Just a second. I will answer in chats. Hello, everybody. It's our Everscale Academy workshop. In this workshop, one of our valuable members will tell you and explain how to create DeBot for Everscale blockchain. And if you wanna to know more about how to start creating DeBots after this workshop, you can go to our YouTube channel, Everscale Academy, and look at it. So welcome, Sui, and let's start.
Hi, everybody. So I'm Sui from Everscale Academy, and as Alex said, the installation process of Tone OS CLI, how to write DeBot, deploying of DeBot, and actually using the DeBot using a DeBot browser. So if plan, this is what we're going to do. We're going to have a general introduction of what Everscale is, formerly known as Freetone. Then a practical demonstration. Then we'll look at a theoretical explanation of DeBot, and then a practical explanation. We shall further continue in the bit more complex DeBot. It's a high performance and scalable blockchain with millions of transactions per second. It is usually considered as a super blockchain, given the fact that cryptocurrency is the Evers, and it is distributed among community members in a meritocratic fashion. Usually, it is distributed through contest. So the objective of the first part is actually to set up a computer so that we can be able to write and deploy Tone Solidity smart contracts. You should you take note that Tone Solidity is a little bit different from Solidity. Tone Solidity targets the Everscale blockchain, unlike Solidity that targets mostly the Ethereum blockchain. As prerequisite, what we need is a laptop, with an operating system installed there. It could be Linux, Windows, or Mac. The recommended OS is the Linux distribution Ubuntu 18.04, but we're going to use Windows during this work. We also need a Solidity to TVM assembly compiler, and we're going to build from sources. You could download as binary, or you could run
Sui, we have some technical problems. I don't hear you.
Utilities. So some utilities we need, we also need some utilities that will link and deploy a contract to the blockchain. And we could build from sources, we could download as binary, or we could equally run in a Docker container. In this workshop, we're going to build everything from sources because we use the Windows OS. So to begin, we installing a code editor, which is and come to start menu. You could just type VS, or you could type in full Visual Studio Code. Then you press, okay, this counts. You press Ctrl+Shift+X to open the search extension marketplace, and then you search for ToneDev. Great. So once you search for ToneDev, you will have you see these 4 different extensions. You select the first extension, and you click on install, and it's going to install.
Sui, we cannot hear you. Maybe something with your connection.
All right, so press Ctrl+Shift+X, and we search for ToneDev. When we search for ToneDev, we're going to get a list of extensions which we'll install. Yeah, so these extensions, you select them and install. I've already installed, that's why I'm showing disable. You can equally go through these, read and find out the different commands that are given to us by ToneDev. I advise to install the rest of the other extensions because they're helpful. For example, Tone Solidity support actually provides explanation to code snippet. And also highlights the Solidity programming language in different colors, making the programming easier. Okay, great. So once you have installed all of these extensions, your IDE is ready for use. So we can then leave that and proceed to the next. The next thing we want to do is to install Git, Cargo, and Rust, because these programs are needed for us to run ToneOS Cellular smoothly. So to install Git, it's easy. You come to Google and you search for install Git, and it's usually the first option. And depending on the operating system you have, either Windows, Mac, Linux, you just click on it and you install it. I've already done the installation, so no need for that. And the next thing we'll have to do is actually to install Cargo. If you install Rust, it comes alongside Cargo, and this is the website. So you could either choose depending on your operating system. So I'm using 64-bit. Install this, and it's going to install Cargo directly. Great. So after the installation of Git, Rust, and Cargo, we now have to ensure that CLI will have to come to the docs.tone.dev, and we come to write smart contracts in Solidity. The process is quite is elaborated here, and with links to all the different repositories. So we want to install ToneOS CLI, and remember, we are building from sources. So we'll right click here, take open new tab in order to gain access to the repo. So this is the repository for ToneOS CLI. So when we're at this level, we are going to go to the desktop or anywhere of your computer. Just choose anywhere. So I have a folder here called Malta, Europe. In it, I'm going to create a folder called ToneOS. And in this folder, I'll create another folder. I'll call it the ToneOS CLI. This is where we're going to clone the repo. So in order to easily do it, we're going to just run the command prompt from here. And we take a git clone. We come to the repository, we come to code, we copy the link to it, and we paste it after the clone. So it's actually cloning the ToneOS CLI repository. While it's cloning, let's scroll down a little bit. All the installation procedure is detailedly explained in the README. So we'll just scroll down to the section where it describes the process for installing on Windows. So here it is, built from sources on Windows. The first step was to clone the repo, which we've done. The next step is to navigate the sec, let the cloning finish up. Great, it's downloading all the different files. So after we navigate to execute, then we run cargo build release and wait for it to execute. Then we can navigate to the target/release folder. Now, the ToneOSCLI.exe, that is the file that's going to inside this repo, ToneOS target/release. In some computers, it is not released. It's actually DeBot. It's found in the folder called DeBot. So we're going to see which one it gives us. It's still cloning. Okay, while it's cloning, I will show you what we are expecting. Great. So I have already installed this, and this is what we expect at the end of it. The repo is going to be cloned like this, and we're going to have all of these files from the repo. And after building, we shall come to target. I do not have release, so I have debug rather. If you open debug, you will find there the Tone OS CLI tool. So this tool is very flexible. You could copy it to any directory and access it from any directory, but for simplicity and organization, I'll choose to leave it inside this folder. So if we run command prompt from there, and we run Tone OS CLI, okay, yeah. So we run Tone OS CLI, yes, with hyphen rather. Great. And then you see, if you see this usage, it means that your command is ready. It means that you've successfully installed the tool. Okay, okay. So that's what we're expecting. So it's still taking some time to download, but since we do not have time, if you follow that procedure, everything's just going to go well because it's quite okay. Great. So the next thing we're going to be installing is TVM linker. That's TVM means Tone Virtual Machine, and the Tone Virtual Machine actually is it's like a supercomputer that is responsible for deploying smart contracts on the Everscale blockchain. So the first thing we're going to do is we are going to come back to the right to the docs.tone.dev, and we'll right click on here where we'll have a TVM linker. Right click on it and we take open a new tab so that we can have access to its repo. So this is its repository. Let's just move one step back, yeah, so that we can see everything well detailed here. So to come to the folder, yeah, we have Malta Euro Tone OS. We'll create a new folder there. We'll call it TVM linker. And inside TVM linker, we shall clone the repo. So we come back to the repository, we copy the link, and we take git clone, we paste the link there, and we clone it. Okay. So cloning, this is we are going to scroll down. The documentation is all there. So we'll scroll down to the section explaining how to build from sources with Windows. Okay, so how to build. We could just copy this at once and run it after it has cloned. It's going to work quite well. So after we have cloned, the next thing will be to navigate to the directory TVM linker, and then we run the command cargo update, and then we run cargo build release. And it's going to build the TVM linker and store it inside the folder release. So let us see. Okay, it's still cloning. So this is what we're expecting. Since it has already been done, let me just navigate to what we're expecting. We have the TVM linker. The file is going to be cloned, and we have all the cloned files. So you come to you navigate to TVM linker. target. In my case, it's still debug. You open debug and you find the TVM linker tool. This TVM linker tool is what we are going to use to actually combine the compiled code and add a standard library to it to have it in the TVM TVC file. Okay, great. So in order to test if everything is okay, you run the command prompt from there. Let's take a look. Yes, here we have tvmlinker.txe. We just run it, tvmlinker.exe. And good. If you see this information, actually give you the version of TVM linker and the rest of this, you are confident that everything was okay, everything is all right, and you can use TVM linker. Great. And last but not the least, install to get going is the compiler. In order to install the compiler, what we have to do is this is it. So come to this repo. We'll right click there and we take open a new tab to have access to its repository. And this is the Solidity, this is a Tone Solidity compiler. So as usual, we'll come back to the folder Tone OS and create another folder. We'll call it compiler. And in compiler, we're actually going to clone the repository here. So we come back to the repo and we copy the link. And we take git clone. So it's cloning the Tone Solidity compiler and it's going to clone it to the folder compiler. Okay, so it's cloning. While it's cloning, this is what we need to do. We have to come here to Windows and see how to install it. So the first thing, as usual, to clone the repo, which we have just done, we have to, after the cloning is done, we have to navigate to the folder Tone Solidity compiler. So let us see if the clone is okay. Okay, Tone CLI not yet done. Okay. So when the cloning once that's finished cloning, then what we have to do is we have to come to the compiler. Yeah, okay, it's still cloning. Let's run it again and so let's just delete this and do it all over. So at this level, we copy the repo link. And we leave it clone. Okay. So once that's finished cloning, the next thing we're going to do is we'll navigate to the folder Tone Solidity compiler, and then we run this command. After that, while inside Tone Solidity compiler, we run the command cmake compiler scripts install dev cmake. It's going to take some time to collect all the necessary packages and build it actually. Then we'll navigate to the folder. We're going to make a directory called build, navigate into build, and then we run this command cmake compiler for it to actually build and give us a soft file. So expecting at the end of it, we have the compiler. This is the clone repo, and we'll come to build. We'll open sulk release, and there we go. This is the file we're looking for. So once you have sulk.exe, you're sure that your compiler has been installed successfully. So in order to test it out, we're just going to run the command prompt from here. And I run the sulk.exe. You see that it's going to produce all of this information. It produces all of this information and it does not display an error code. So once you see this information and you are sure that the compiler has been installed successfully. Now, just for your understanding, you have to know that when we installed when we install the different extensions for ToneDev, automatically it came with the compiler and TVM linker. So it came with the compiler and TVM linker. For that reason, we'll be able to easily compile smart contracts from the IDE rather than actually doing it, or rather actually following the commands that are given on the website. So great. Now that we've installed TVM linker, Tone OS CLI, and the compiler, then we can be confident that now the most interesting part, DeBot. So what is a DeBot? A DeBot is a secure chat-based interface that allows the user to interact with smart contracts on the blockchain. It can allow the user to access the different methods that have been deployed in a particular smart contract on the blockchain. So, and these DeBots can be used and accessed through DeBot browsers. Now, DeBot contains three main components: DeBot interfaces, the DeBot browser, and the target smart contracts. So DeBot interfaces, they are equally smart contracts, but these smart contracts run on the DeBot browsers. And they produce some sort of a user interface for the user to be able to interact with the target smart contract deployed on the blockchain. DeBot browsers, on the other hand, they are engines that are capable of running DeBot interfaces, and they give a chance for the user to search for a particular DeBot using the DeBot address. If you have the DeBot address, you can use the DeBot browser to fetch that particular DeBot from the blockchain. Okay, great. So let us look at the practical demonstration. We are going to start. So the best way to do this is actually to clone a repo. So we'll come here. Now let's go to desktop, Malta. So we're going to create a new folder here. Let's call it Malta DeBot. All our files are going to be inside here. So, well, first of all, we're going to run a hello world DeBot, and then we are going to write now a more complex DeBot. We hope time permits so that we can finish it up. Okay, great. In order to run the hello world, what we will do first of all is to navigate to the Tone Labs, which will navigate to the Tone Labs sample code. So we'll just search DeBot for Tone Labs. Okay. Okay, this is unusually slow. Okay, great. Okay, since it's slow, we'll just copy it from somewhere which we have. So, well, everything that is here is actually what is in that repository. So we can just bring it in here. Our goal is to actually run and deploy this smart contract, the Hello World smart contract. So just take a look at the structure. Outside, we have these other Solidity files, menu.sol, confirm input.sol. These are actually DeBot interfaces, and these DeBot interfaces are they are developed by community members. But when a community member develops a DeBot interface, he has to submit it to a consortium that is going to study the DeBot before adopting it. So when it's adopted and accepted, then it is then now published on the GitHub for community members to use it in developing DeBot. So of course you can always browse to this repo, and you see the this is it, the DeBot interface consortium. So in this repository, you can see all the DeBots that have been proposed and studied already by the DeBot interface consortium. So these are the DeBot interfaces which you can use. If you open each one of them, it actually has an example and a README explaining what it does. For example, this one allows the input of smart contracts. So this is it about terminals. And here we have now the target smart contract, and in this target smart contract, we can import those interfaces and have a use. So we're just going to, from here, we're going to run the command prompt from this interface and launch the IDE from there. The code editor it actually runs Visual Studio Code. So our the folder which we have is Malta DeBot. Yes, Malta DeBot, and our goal is to run this smart contract. So in order to avoid confusion, we're just going to delete all these other files because we do not need them. Yes, so I'm just going to delete that. Yeah, delete that. Okay, and yes, move them to the second bit. So now we are left with the hello DeBot.sol. So let's just briefly discuss on what's in here. So first we have these pragmas. These are the first lines of code are the pragma derivative. Yeah, if you hover over it, it actually gives you a brief explanation of what it does. That is because we installed those extensions. So the very first pragma, Tone Solidity, actually describes the version of the Solidity compiler which this smart code is written for, and it's going to apply to the rest of the file since it's local. Next, we have the headers, expired pragma ABI expired time. So you have, yeah, you can actually see the different explanation because it actually tells you the different the time and So it actually gives you several different information, like this is the public key that can receive public key from the user. Then the next thing we'll be looking at is the import statement. So the import, so basically at this level, we import the different interfaces which we're using. Dot simply means it moves one folder behind and then it finds a file here. Since the interfaces are just found outside of the main folder. So if you look out of the main folder, you find the DeBot, you find the terminal, you find menu. Yeah, menu is there. So you find menu. So they're all there. Yeah, if this is menu, you find menu, you find address input too. Great. Immediately, so after that, you have now the contract for the DeBot. Now, and of course, the keyword is contract, and the name of the contract is Hello DeBot. This is a keyword that signifies inheritance. So it basically inherits DeBot. Everything inside this DeBot.sol is going to be copied into the smart contract for it to run. So this is the meaning of this is. You could actually put a comma and inherit other files if the functions that are needed, of course. Then the next function we have is actually this one. This function actually requires the user to input its public key. So if you see tdm.pub key, it's going to ask the user it's going to take the public key from the user and it's going to check if the public key of the user is actually the user's public key. If it's not, it's going to display a 100 exception. Then we have tdm.accept. tdm.accept actually sets the gas limit to its maximum allowed value, and it's also necessary for the processing of external messages. Immediately below it, we have the start function. This is a function this function actually implements a little part of DeBot because it calls the print function from the terminal interface. So this is the terminal interface. If we come to the terminal interface, you're going to see that it has two main functions. It has three main functions: printf, print, and input. So the print function actually prints out the message which the user has inputted, and input actually it receives strings from the user. Okay, great. Okay, so here we go. So that's basically what happens at that level. And this is just a function that produces information about the DeBot which you're producing. So it's all the information about the DeBot, the things like author, publisher, the language, all of it is written there. And then we have this other function that gets the required interfaces. The main interface we use here was the terminal. And finally, this last function, it simply calls the print function from the terminal interface to display what the user has inputted. So let's just do a little bit of modification here. Okay. So that we can be able to see what the user has inputted. Now, the next thing we need to do is actually to compile this DeBot. It's just a hello world DeBot, very simple DeBot that we're going to compile it and deploy it. Then we shall move on now to the complex DeBot. So in order to do the compilation and deploy, once you're on the IDE, there are two ways. You could right click and you take compile solidity smart contract, or you could come to view command palette and you type you type tone dev. Once you type tone dev, you're going to see the different commands that are associated with the extension which you've installed. Here we also have the compile solidity smart contract. We can just click on it directly. And there we go. It has compiled already. So here we have the file. So you'll see that the code was generated and saved to file. Sometimes it saves in the directory for which it was created, but sometimes it comes to the app data. It comes to app data to store it. So in order to access the files that have just been generated for it, there we go. Hello world ABI.db, the hello DeBot. We have the ABI.json and the .tvc. So we're just gonna cut it off since we want to. The reason why we're cutting off is to take it to the main directory so that we do not have several directories that we're working on. So we have the Malta DeBot, the hello world. So we're just going to paste it here. Here we have the ABI.json and the hello.tvc. So we have the ABI.json and the hello.tvc. Great. That what has actually happened. So let us explain briefly what has just happened right now. So what has happened is that we have had our own smart contract here, which in this case is DeBot. Then we have compiled it. So what we're supposed to do with this command and this command, the IDE has done that for us very easily. So what happened was that, first of all, the IDE used TVM. The IDE used the compiler to produce a .code file, right? To produce a .code file. The .code file was then used by TVM linker, and a standard library was added to it to produce a TVM bytecode. That TVM bytecode is what we call the .tvc file, and that .tvc file is going to be used in deploying. So we are now at the level of deployment. In order to deploy, so we have two main networks. We have the main network and the development network, but this is just for tests, so we're going to be dealing with the development network. And this is the link to have access to net.tone.dev. Okay. So the very first step, what do we do in the deployment? We have to first navigate to the path that contains ToneOS CLI. So as we've just installed, so we'll navigate to the path that contains ToneOS CLI, target, debug, and here we go, ToneOS CLI. We'll run a command prompt from there. And then the next step, after navigating to the path, we have to type this command, ToneOS CLI configure, and yeah, this command actually links us straight to the development network. Great, succeeded. So we can be confident now we are linked to the net.tone network. So everything I'm going to do is going to be done on the development network. Great. The second step is actually to generate the raw address, keys, and seed phrase. In order to do that, we still use the ToneOS CLI tool and the gen address and the gen key commands. So we just copy the. We will use Notepad. So we use Notepad in order to arrange the different parts. So because this wallet address of TVC is actually requesting for the TVC file which we have just generated, and we have to put it respecting its path. So in order to do that, we will rapidly come to the IDE. And here we have the TVC file. Here it is, hello world. So I have the TVC file here. We'll right click on it and we'll take copy path and paste it there. And then the next we have wallet ABI.json. Yeah, so we'll rapidly come here. Yeah, we have the ABI.json. So right click on it, we'll take copy path and paste it there. And then the gen key keyword, and we have wallet, wallet.keys.json, but this is going to go to the to the directory where tone.os CLI is located. So we have to modify the path and change its name so that we have something similar. Well, I'll let us take something like this. Let's just copy that path. Now you see that I've just taken the path, excluding the extension, so I'll replace that here too. Great, and well, so we shall have a new file, hello debot.keys.json. Great, I think mine is ready, and we can run it right here. Excellent. So the seed phrase here, we have a seed phrase, and we have the raw address that has been generated. And of course, it's on the testnet, and it succeeded. So if we come here, we'll see that we also have a new file, which is the hello.debot.keys.json, which has also been generated. This we use to sign, we could use to sign different transactions in relation to this particular smart contract that we just deployed. Excellent. So we have that now. The next thing we want to do, we'll finish. So we have generated a raw address and the keys. The next thing we have to do right now is actually to fund the account. So in order to fund the account, so one thing you have to know, by the way, is that all Everscale accounts are fundable, means they can receive tokens. So this account already is capable of receiving tokens, and the tokens will be used for paying transactions that are related to these accounts. For example, if we want to deploy the account on the blockchain, we need to pay for the transaction, and this account will need to pay for it because everything on the blockchain is paid for. So in order to have development tokens on the Everscale blockchain, for now we call them rubies. In order to have some rubies, you could ask a friend, you could ask me, or you could ask in the developer chat, or you could ask in the community, and definitely someone will send it to you. So but before we do that, let us test the account. So let us check the state of the pre-deployed contract, right? So in order to test the state of the pre-deployed contract, we'll use this account. We'll use that command. So we can just paste it there, and we'll copy the raw address and replace it right there. Okay, it's processing. Now, it will definitely show not found because the account is empty. And of course, you could also check on the tone.live. You can also check on the tone.live to see if you can find the account there. But okay, qualify. So let's just repeat that. Probably network issue. Great. Succeeded, but account not found. Okay, account is not found. The reason is simple. It is because it's not funded. So at this level, we'll have to fund this account. And to fund the account, it's easy. There are two ways which you can do it. You could actually use this command to fund it, right? You use this command to fund it. But on Windows, you have to know that this work well on the other operating system like Linux, Macs, but on Windows, this external single quotes will change to double quotes. And then before each of these double quotes, we're going to paste a backslash, okay, a backslash. So you could come to decentralize, you paste a backslash there, yeah, great. So once you do that, it's going to work, but I'm not going to use that. I'm going to use a simpler method. So I'm going to use to advanced settings, network, and we choose DevNet. Of course, the connectables are great. Now we're on the DevNet network. Let's wait for the tokens to load. Excellent. They have loaded. So we have your, yeah, that should be sent. And we're sending to that address. Let's send two, no, 1 rupees. Transactions are extremely cheap. So we need to waste the money. After. Okay. Okay, let me copy that address again. For some reason, it did not copy, so paste the address right there. Rupees, yeah, maybe 2 rupees. Also. Okay, for some reason that's not okay, but let's try it again. 1. Oh. Let me just refresh that. While it's refreshing, we explain a little bit about funded our account. We'll be able to view the account on tone.live, and so we can always come to the development network there because that's where we are. We'll be able to view the account there, and also we can also use the, of course, the command line to view it there. Great. So okay, that is extremely slow. That's not nice. Okay, because it's slow, I think maybe we should just use this. Proper network connection. Okay, so we'll just use the command, right? And work on it. Okay, so at this place, we'll put your address there. Address there. Send transaction. We change this to double quote, and we change. We'll change it to the double quote. Let's see this here so that we're faster. Definite, yeah. The same. Anyways, let's work on this one. So destination address, here's value. So these tone crystals are actually expressed in nanos. So 10 0. So this will be like sending, let's see, 3 3. So it's let's add 1 0 there so that we're sending 1 tone. And we change bounds to false. It's actually in the documentation. If we leave it to true, it's going to go and it's going to return. And then at this level, we're going to put the yes, the ABI.json file, the links will come here. We have the ABI.json, right click, we take copy path and paste it there. Paste it there. And then we'll have to sign with the keys. So I have to validate the keys of JSON. So this is where the keys also are important. We'll right click here, I'll take copy path and place the key there. Okay. Okay, I hope that works. Okay, let's see advanced settings, network. Sorry about this. Sometimes, okay. Okay, great. Let's just wait for this to work. I'm not sure this is going to work. Okay, let's see this. If it doesn't work, then I will know why. Okay, yeah, of course. The reason it doesn't work. The reason is because this we've used the wrong key. This key actually is for this particular contract, but we'll have to use the key for the wallet address that contains the token. So we have to get the keys from here. Okay. Anyways, what we'll do, Alex, are you online?
Yes, I'm online. Yes, I'm here.
Okay. So what I'll need you to do is I'm just going to paste address. If you can send some test tokens to it, is going great.
Sorry, what I need to do?
I need you to send some rubies, some test tokens to this address so that we can be able to deploy it. For some reason, ToneSolve is not working very well on the computer. It's not showing the same interface.
Okay, I will try to find the wallet with test coins because I don't have test coins. I have.
Okay.
If you wanna, we can deploy it on the mainnet. I can send to mainnet some coins to mainnet.
Okay. All right, then no problem. So yeah, okay. The mainnet then very quickly. Yeah, it will be main.tone.dev. So we'll copy that and we'll paste there and we'll change it to main.tone.dev. Great. So now we have this same contracts here, but we'll just use the same commands which we used before for simplicity. So here we have them to generate the address. So we'll copy that same command and paste it right here. Excellent. So this now we're on mainnet, and this is actually the command for it. So I'm going to send some. No, you don't even have to bother about that, Darwin. I can do that right away right here. I'm going to send some tokens to that smart contract on mainnet. So I'm going to send. So I could just put maybe one. The recipient and call it Malta. Then we can input the passwords. Okay, it's calculating. Give a sec. while it's going, we shall observe it from the transaction here to see. We have transfer in progress. So while waiting for it, we can of course test the account here. We can of course use the ToneCLI account to test it. So we could always okay, excellent. We have the transaction has succeeded and we have one tone. So we can now deploy this smart contract actually on mainnet.
Great.
Now, yes. So the next, at this level, we see that we have actually funded our smart contract. So we can now proceed to the next step to actually deploy it on mainnet this time around. So that's great. So to do that, we are going to use this command. You see, 5, deploy your contract to the selected network. So on mainnet, so we're going to just copy this command. And we come here. We have ToneCLI, we have the avi.json. We'll copy avi.json. We'll copy the path. There. Okay, we'll give it a space. Sign, wallet. We have key, wallet.keys.json. Here we have it. Hello to keys.json. We will copy the path and we will replace it there. Yes, copy path, and paste there. And then we have the contract.tvc file. So we have the tvc file here. We will copy path and we'll place it there too. And of course, it takes no argument. The contract, it takes no argument. So we'll remove that and we'll copy that and run it right here. So we'll paste it right there and execute. Okay, great. So it is deploying to mainnet. So it's connecting to mainnet and it's going to be deployed to mainnet in less than a second. Okay. Succeeded. Excellent. So so it has the contract has been deployed to this address. The next thing we want to do is actually to rapidly test the account again. Now you see that the back of files contains information and the transaction fee has equally reduced. All indications that it has paid for its transaction, and now the network has information about the smart contract. So we will rapidly test this smart contract. So remember, it was deployed to this address. So in order to use this deployed, there are two ways. We could actually use a ToneSurf browser, or we could use the Extratone browser. So these are two popular DeBot browsers that we can use to access our smart contracts. So of course, you just type this link dbrowser.extratone.io and it will give you access to this site. Since we're on the mainnet, it is, yeah, so you see mainnet, we have by default it's on mainnet, so we just have to paste the address there and search. If you click on this question mark, you will see, great, it has found it. So we will click on launch. Hello world, and we have how it's going. You can see fine, and then we see, okay. There's some error in the passing there, just code error, but you see, we are able to deploy the smart contract already on on mainnet. So any person anywhere, you could directly connect on mainnet and you'll be able to have access to this DeBot. Okay, great. Now, there are other ways in which we could also deploy smart contracts. Like we could come to the ToneLab DeBot repository, and the README will have a subtopic how to run, and there we have the mainnet, we have DevNet, and we have the mainnet. So if we copy, since you're on the mainnet, if we copy that, this is for the Everscape mainnet, this is the DevNet. So we have to just copy this and we replace this address here. Great, so let's do that and I'll test it out and see the effect on this ToneSurf DeBot browser. Okay, so at this level, we are going to replace, copy the address to which it was deployed. That's the address. Yep. And we just place like that. Yeah, and it's going to fetch it. So we can copy that and place on browser. Directly is going to launch the ToneSurf, the web ToneSurf, and it's going to search directly and get okay, connection is slow. So it'll just wait, it's going to come back, but it's going to launch the ToneSurf and search directly for this DeBot browser. And it's equally, all right, it's extremely slow. So, but nevertheless, we could always come here on DeBot browser and enter the address there.
You are in DevNet now in your WebToneSurf. I think you need to change to mainnet.
Okay, thank you. Great. So give it a sec for it to start to reboot. Great. Okay. So so at this level, right? While waiting for this to while waiting for it to go to the mainnet, this has it has actually, let's wait for it to load so that we can input the key, and it's going to search to see we're able to use it there. Connection is a little bit slow, but you know, when launches, we're going to see the DeBot browser which we've just deployed. Okay, still loading. Okay, just poor connectivity, that we do not waste time too much. So basically, this is how you can write. You can write your DeBot. You can actually deploy it to mainnet directly with at less than 1 tone. You also it. We've been able to deploy a DeBot with less than 1 tone, and we already have the DeBot browsers that are there to help us use the different DeBots. Okay, we have the web DeBot browser and we have the mobile DeBot browser, which is the ToneSurf. Okay, great. So it's still very slow. We will well, in order, since we are already 6 minutes ahead of time. Okay. In order not to continue waiting, anyway, I'm sure you get the gist, because this will just launch directly and open the DeBot browser and you'll be able to use already. So the secret is just to replace where you have address with the address to which the DeBot browser, with the address to which the DeBot was deployed on blockchain. Okay, great. So that is it for the first part. Now let us move to the second part, which is building a little bit more complex DeBot. I hope we get time. Alex, can we go ahead with that?
Yep. Yep. Sorry, some sound problem. Do you finish? Yes. Hello.
Hello, yes.
Yes. Yes. Do you finish? Do you finish?
Okay, yeah, so let me finish this part. So they say, no, okay, now we are on mainnet and you can see this DeBot can threaten the security for your data. No problem, just continue anyways. And there you go, hello world. So this is how you can also use questions before we move on to the second part, if that's okay. Are there some questions?
I think we haven't questions because it's YouTube broadcast. Everybody just see us on YouTube. On YouTube, I don't see questions. That's why yes, we can move on if you finish or if you finish.
Okay, great. Yeah. So with that, we can say that we have come to the end of actually writing a simple DeBot, on being able to use the extra tone browser and the tone serve. This time around, we did the deployment on mainnet. So now, a little bit about the structure of smart contracts. Smart contracts generally have four main parts. The first part is the pragma, and the next is the import, and we have, so pragma derivative actually that defines files, key files that are local to the particular smart contract which we're writing. Then we equally have solidity files that have codes that we would need in our current smart contracts. The import is going to be very useful because comments, like every other programming language, comments are there to we have block comments and line comments, and they are there to give explanations to the different code snippets for easy readability. And then we have the contracts, libraries, interfaces. So for this particular DeBot, what we're going to do is we're going to write a DeBot that can collect names of different persons and displays them. So this DeBot is actually going to collect names of persons, store them in some form of persistent data storage called mapping, and we'll be able to, and we'll use DeBot to call them and display them. So technically that's what we're going to be building. Okay. So in order to explain more, the persistent data storage that we'll be using is structured. It's similar to what we know in web, like a relational database table. Is like the entity, and is going to be person, like, so the name of the entity is person, and then the items of the structure, we can have maybe person ID, the first name, last name, wallet address of that person. These are the different items of that structure, and it is synonymous to attribute. It's synonymous to attribute in the relational database, so that I want to move you from what you know to what is a little bit complex to understand, but very short code. So build a function to, well, first we shall create a structure person with different types in it. Then we create a function called create person. We create another function called delete person. And then we create a function called send token so that maybe you could send tokens to a particular person if you choose. And then we'll write a getter function. Then we shall build a DeBot logic that is going to be able to receive input from the user and send it to the smart contract like that, right? Great. The best way to get started is actually to, if you look on the chat, I've put a series of links there. So you can actually go to a repo that I've created to help generally in the development, in the rapid development of smart contract. So let me just go there. Okay. Wow. Network is extremely slow here. Okay. This is extremely slow. So what I will do is I will check if I have it offline so that okay, we have the Malta start. Okay, this is it. So well, I've created a repo, we'll call it the academic starter file. This repository actually contains all the it contains all the interfaces. It equally contains some tutorials, some test tutorials, which you could actually get inspiration. You can use test sheet version 4 to actually test your smart contracts after you've written it. So these smart contracts have been written covering different scenarios, and we have these different test scripts written in Python that can help you test if your smart contract is working the way it's supposed to be. And then we have a folder DeBot. Yeah, these are just some test files, but they're not important. You know, we could always take them out. And we have one script, app.sol. Yeah, so this now let's open that on the code browser. Great. There it is. So there we go. As for explaining, we have the DeBot, we have the app.sol. So these are just some codes that have been written, but if you come to the GitHub repo, okay, it's still very slow for some reason. I don't know why. But if you come to the GitHub repo, you actually see that on the GitHub repo, all the interfaces have been imported and they have been commented. So there is a comment explaining what each interface does. But for simplicity, this is actually a target smart contract that have been written for the DeBot which we intend to write. So well, I'm just going to explain briefly what's happening inside before we continue. Great. So at this level, so the first thing we have to do is, well, as usual, we can import the quotes that we import the library. We need terminal.sol. And don't forget the semicolon. Of course, we can repeat that numerous times. And then we will need menu. Yep, menu.sol. We need DeBot.sol. And we will also need upgradable. So terminal will allow us to receive input from the user and print it out. Menu will allow us to be able to produce buttons on buttons on the DeBot so that user can click on the button and it's going to execute a particular function which has been written inside a smart contract. DeBot and upgradable are always inherited, so we will put is DeBot, comma, upgradable. So yeah, so that thing upgradable. Okay, great. So so what happens at this level? DeBot and upgradable, all the codes from here are going to be copied into this contract for it to are going to copy into it, since this is a sign of inheritance. So the very first thing that we do here is actually to create a modifier. We call the modifier only owner. So what this modifier does is, a modifier first of all is defined to change the functioning of a particular function. So it's defined to change the way the next thing we do is we create a constructor. This constructor verifies if the user public key is different from 0 and 120. If it is, it accepts and then it stores the public key in M owner. And that M owner is then now stored in message.public. The next thing we're going to do is actually to define this, right? So if you look at this, so we want to define a structure called person, and it has it takes integer, f name as string, l name as string, and address as an address. So if you look here, you're going to see that we have uint PID. These uint, it means unsigned integer, and there are different kinds, right? It could be uint 64, but I just prefer to use uint because it's equivalent to 256. So this is like uint 256. It gives you the range for which that integer value is. But it's always good to use the smaller ones if you know exactly what you're doing, so that it reduces the cost of your smart contract. Next, we could define another variable, f name as string, l name as string, and then p address as address, and we close the struct. So we have a struct called person having these different attributes. Now, how do we make it like this? So we have to use a mapping in order to make it so that we can be able to store data onto that mapping. And in order to do that, the mapping which we will use is yeah, okay, so this is what we'll do. What we'll do is we have to write a keyword mapping, and then we have a key and a value. So the key is this unsigned integer and the value is person. Then we define like an object to the mapping persons, because if we want to browse through this mapping, we'll need this object. So we have the key value, right? And these persons will help us to navigate above to index to the next. So after doing this, we'll move on to the next step, which is to create a function called create person. Okay. So in order to so this is the function called create person. You write function create person, which takes into parameters, of course, the name, the first name, the last name, and the address of the person, because that is what we're going to be receiving. And then the access modifier, public, and then that only the person with the public key have access to this function. It is some sort of a security measure. Then we have TVM accept. It's always good to just put TVM accept in front when you begin every function, because as we explained earlier, it sets the gas limit to the maximum limit that is allowed and is necessary to process external messages. Then remember we had defined a variable here, p count, as an unsigned integer. So we increment p count. The reason why we're incrementing p count is because we are going to be using it to change the index of the mapping. So so we have persons p count. So whenever p count is incremented, the index of the mapping is changed, and then what happens is that we then store in the mapping the p count, which is the PID, f name, last name, and the address. So that this is what happens at this whenever this function is run, this happens, and so the data keeps storing on the different indices on the mapping. Great. The next is delete person. Of course, yeah, we write the function delete person. It takes into parameters the ID, the person ID, and then access modifier public, and the modifier only owner. This time around, we have to test if the PID, that's if the ID exists. If the ID does not exist, it displays a 102 error. But if it exists, okay, yeah. If it exists, we'll of course we'll do tvm.accept, and then we'll call it, we'll delete that that particular ID from the mapping. Okay, it's deleted from the mapping, not from the blockchain, because nothing, of course, can be removed from the blockchain. Okay, then the next function is the send grams. So basically, this function will help us to send tokens to someone who is using this DeBot. So we'll have address p address, we have the amount, we have the bounds. Of course, these are attributes that this function receives, and then we use pure the access modifier pure and public. Pure simply means that the state variables in here cannot be modified and cannot be read. So that's meaning of pure. It's similar to the view statement, which we're going to see subsequently. So great. After that, we take tvm.accept, and we do p address.transfer. We take amount and bounds. Of course, if it's not one the funds to be returned, you have to use false. That's why it's bool, meaning it's either true or false. So if you use false, the funds are going to be sent and not be returned. Okay, and we set an unbounds function that simply tests if the body.bit is equal to 0. Okay, the last thing we're going to do is actually to write the getter function. Okay, so we'll write the getter function. Great. So we'll write the getter function here. Great. This getter function actually it actually gets the information that we have been populated in the mapping. So we can use the getter and then we'll be able to use it out easily. And so in order to do that, we write a function get person public view. View means that you can read the state variables, but of course you cannot modify it. So it returns, and the getter function also always returns a value. Okay, keep that in mind. So this getter function returns an array called m-persons of type person. Okay. Now the reason why we are passing an array into parameters is because we are going to be pushing all the items which we've collected from the mapping above into this array so that we can easily access it. Okay, so we define some variables like fname, lname, p address, and then we browse through the mapping using this. So for every ID on the person mapping, we use persons to browse through each one of it. So for when we move from each index, we're going to collect the first name, the last name, and store it in the variable, and also collect the address to store it inside the p address. Then we push it inside the array which we pass into parameter person. So push it inside the array. So that's what happened in the target smart contract. Then the next exciting part is actually to write the DeBot logic for it. Okay, great. So in order to do this, for this one, I will not do it today. I want to do it in the next workshop which we're having. I hope it's okay because we've already used 1 hour 30 minutes so that we could prepare for the next workshop. Alex, is that okay?
Yes, it's okay. Let's continue on the next week. I think we can do one more workshop about this. Yes.
Yes, of course. Where we'll write the DeBot logic that will actually collect, that will actually link the front end to this back end, so that we can get a feel of it.
Great. So everybody who watch us now, because I know that actually Malta event is coming over now, but it's not a problem because everybody who will see this video can look it on YouTube, and we will continue to advertise it more to attract more people. Thank you very much, Svi, for your great learning educational video. And so looking forward for more and more workshops. Thank you really very, very much.
Thank you too.
Okay, thank you everybody who come and everybody who will watch it later. So goodbye to everybody, and thanks one more time for this sweet. Thank you.
Okay.